Assalamu alaikum wa rahmatullah. Hello again with our course Microcontrolling Start as Professional. In Module 8 we will speak about one very important concept that is used in microprocessors and of course with microcontrollers. So by the end of this module you are going to understand the nature of interrupt, what is interrupt, and how to use it to do some very useful applications. So let me explain first what is the interrupt for those who don't know what is interrupt. So in any embedded system, it's often performing a task which is not frequently happen or maybe unpredictable. The unpredictable things is the interrupting thing. As we said before, like any microcontroller is doing loops. So it's repeat the same word continuously, checking sensor, do some control for motor, for light, for other things. Now, if I want to do something that not generally happen, I use the interrupt. For example, you are using your smartphone and suddenly a call come. So what will happen? Your game or your whatever you apply on your smartphone will pause. You can catch the call, answer it, and speak with the person who is calling you, and then close and go back to what you are doing. So this interrupting action is the interrupt. What will happen in the microcontroller? It will stop, pause, save the data at the position where it is, and do the interrupt action and go back to it. Another thing, if you are in the gas station and something happened, so stop filling oil and start alarm in case of emergency when you push the button. So pushing the button, you interrupt the process of filling the gasoline into your car. So regular task must be temporarily stopped to deal with the event, the interrupt event. Interrupts are the unusual events. How to deal with interrupts? We need what's called interrupt handlers. So interrupt handler or interrupt service routine are functions or part of program which perform the necessary task. To understand more the concept of interrupt, let's suppose that you are in your house sitting on the couch and watching a movie. At the same time, you are waiting for an important package to arrive. And this package is important for you, so you need the package as soon as possible. If you are a normal AVR program, so the one that is doing the loop, you have to stop the movie and go check the mailbox every 5 minutes or so and come back. So as the loop, every 5 minutes or whatever the delay time, you go check, go back, continue. So this is the normal routine. But if the package is going to be sent by a courier which with a delivery confirmation, so the delivery man will go to your front door and ring the doorbell as soon as he arrives. So this bell ringing is the interrupt action. So the bell is your interrupt trigger. Once you get the trigger, you can pause your movie and go to deal with that package. As soon as you're done, you get the package, you can pick up the film where you left off without wasting extra time. So this is the concept of interrupt. So to deal with interrupt, we need to understand different features and registers and routines or functions that is used inside AVR microcontrollers. So when interrupt event occurs, the microcontroller pauses its current task and attend to the interrupt by executing an interrupt service routine. So interrupt service routine is a function. At the end of the ISR, the interrupt service routine, the microcontroller returns to the original task and continue its normal operation. In AVR, there are different types of interrupts. Interrupts has different sources. The reset interrupt trigger from pin 9. We have 3 external interrupts: interrupt 0, interrupt 1, and interrupt 2. They are here, as you can see. Pin 3, you have interrupt 2. At pin 16, you have interrupt 0, and pin 17, interrupt 1. And for the reset, it's at pin 9. So if you apply reset bar, so that means if you apply 0 here, it will stop all the program and start from the beginning. We have also what's called the timer interrupt, and there are 2 types of them: overflow interrupt and compare match interrupt. I will give small introduction about them now, but we will speak about them in more details when we speak about the timers. So in this module, I will focus on the external interrupts. Now, interrupt, as you can see, interrupt 2 is the same bin with PB2, and interrupt 0, interrupt 1 are the same bin with board D, BD2 and BD3. So how the microcontroller know that this signal is input from the board or it's just the interrupt? We need to use the concept of enabling. So as we said, in status register there is a special bit here. This bit is for interrupt. So when this bit is set to 1, that means I enable the interrupt. So bit 7 of status register, which is the I bit, is the global interrupt enable. Clearing I bit disable interrupt and set the I bit enables them. So enable and reset, I think you are more familiar with this thing. So if you want to enable something, you click it, so it will change from the status 0 to status 1 and an indicator will open. In your car, in your devices, there are something like this. So when it's pushed, the button is pushed, the status will change to on or off and the LED will be on or off. The same concept is applied using the registers in microcontroller. So when we want to enable the interrupt, we set bit 7 in status register to 1. That's mean enable interrupt. So now the bin will not work as board anymore, they will work as interrupt. The I bit is automatically cleared when the interrupt starts, set when interrupt is done. So it's cleared when start and set again back to done. That means there's no interrupt during the time of the interrupt. So when the interrupt start, it will be cleared, so no more interrupt. So disable the interrupt during the current interrupt. There are special functions we can use or macros which called SEI, so set interrupt, and CLI clear interrupt. So instead of accessing a status register directly, you can use these two functions. Now, how to deal with the interrupt? We have 3 registers. We already speak about one of them, which is status register. There are other 2 registers. One of them is GICR and the second is MCUCR. So if I want to enable the interrupt, as you can see here, this is the GICR, which is General Interrupt Control Register. So I care about the bit 5, 6 and 7. So each one of these bits is a local interrupt. So the I in status register is general, that means global, that means all the interrupt is enabled or all the interrupt is disabled. Now if you want to enable one by one, so after enabling the status register bit 7, you can decide which one will be enabled. So if you want to enable interrupt 2, you set 1 in bit 5. The same for interrupt 0 and interrupt 1. How to set it to 1? So use the shifting. So we shift the 1 at the number of interrupt 1 and the number of interrupt 0. So how can you understand this? That means in GICR, set interrupt 1 to 1 and interrupt 0 to 1. So enable interrupt on interrupt 0 and 1. There's another register, it's called the MCUCR. So this is the MCUCR. As you see, it have this 4 bits. So this 4 bits actually is to decide the way of the interrupt. So for example, let's take interrupt 0. So these 2 are for interrupt 0. So if it's 0, 0, that means low level of interrupt generates an interrupt request. So change from 1 to 0 on bin 16. So if I change the level from 1 to 0, the interrupt will trigger. If I use 0, 1, and logical change, so from 0 to 1 or 1 to 0 will call the interrupt. If 1, 1, the rising edge. So that's I decide how the interrupt is going to happen on the levels of the pin. Now I have 3 registers to decide how to do the interrupt. The global enable, the GICR to decide which one to be enabled, which one not to be enabled after enabling the global one, and this one to decide how the interrupt is going to be happen. Is it on falling edge? Is it on rising edge? Is it on state changing or on 0? When the interrupt happen, I mean, for example, if I choose this case on the falling edge, when a falling edge happen and we are already enabled the interrupt, so this function will be called. So here this function is ISR, and here I give it a vector name. So ISR is interrupt service routine for a vector name. A vector name can be one of the interrupts or the overflow or compare trigger in the timers. So interrupt actually has places in the memory, and this is their addresses, but we don't need to care about them because the header file will take care of them. So example, if I want to use interrupt 0, I write the ISR function and give it the parameter, so the vector will be interrupt 0 vector. If I want to do overflow on the timer, I pass this value to the ISR function. Now let's speak a little bit about the timers. So we already finished speaking about the external interrupt. Now let's speak about the timers. So Atmega 32 has 3 timers. The number of timers is changed by the microcontroller that I'm using. For example, Atmega 2560 have 6 timers. Our focus in this course is Atmega 32 has 3 timers. 2 of them is 8 bits and 1 16-bit. As I said, I will explain about them later, and you can find detailed explanation about them in the data sheet. Timers are used to generate interrupts and also can be used to generate pulse width modulation, PWM, as we will speak about later. To use the timer interrupts, again we need to deal with some registers. So the main register for interrupt is status register. So if you remember, here we have the bit I in status register. In external interrupt we have GICR and MCUCR. Very similar in timers. We have some registers to deal with. So first one is global interrupt in the status register. Then we need to deal with this register. So I'm not going to speak about all the registers for all timers. I will just take an example of timer 0. I'm going to speak in details about them later on when we speak about timers. So for interrupt now, I just focus on these registers. So we have the TCNT0 register. So this register actually is having the value of the timer because the timer is going to count from 0 to its maximum. So if it's 8-bit timer, it will count up to 255. Okay, so the value of the timer is stored in this register. Now we have the other register, which is TCCR0, timer control register. So this register will control the prescaler and control the mode. So if I want to use it in full time timer, I mean the counting to the maximum, or compare or so on, is this register is where I need to change. Related to interrupt, I have for each timer in the TIMSK register. So I have the TIMSK register is for all the timers, and for each timer on the 3 timers of Atmega 32, we have a enable disable interrupt bit. So these 2 bits are for the timer 0. So TOIE0 is timer overflow enable, and OCIE0 is output compare interrupt enable. So each timer have 2 types of interrupt, as we said. One is overflow and one for compare. Again, I'm not going to speak in details here. When you go to the module which is speaking about timers, I will give you full details. Okay, so we need to enable the global interrupt in status register, and we need to enable these 2 interrupts. How we know the interrupt has happened? From the interrupt flags in the register TIFR0. Okay, so TIFR0 for timer 0. So here we have 2 bits. One is TOV0, which indicate that overflow in timer 0 happened, and OCF0 indicates that compare interrupt has happened. So when the interrupt happen, when the timer reach its maximum, that means overflow happens. So this will change to 1. When we set a compare value and this compare value is reached, so this bit will change to 1. So that means I know that the interrupt happens. then when the interrupt happens, the ISR function will be called. So that's all. I will show you examples in next videos. Thank you for listening and see you in the next videos.